we're going to be finding a quadratic function given 3 points that are part of the function. We're told that the quadratic function has x-intercepts -2, 0, and 7, 0, and a y-intercept of 0, 8. We're first of all asked to find an equation for the function and then to find its maximum or minimum value. We'll start by realizing what a quadratic function looks like. Quadratic function will be something of the form f of x equals ax squared plus bx plus c. I have 3 points, so I can substitute for the first point -2 for x and 0 for f of x, and that will give me one equation with a, b, and c now as the variables, because that's what I want to find. Substituting 0 for f of x and -2 for x, I have 0 equals a times -2 squared plus b times -2 plus c. Now I substitute 0 for f of x and 7 for x. This gives me a times 7 squared plus b times 7 plus c. And finally I substitute 8 for f of x and 0 for x. This gives me a times 0 squared plus b times 0 plus c. And I can simplify. I have 0 equals 4a minus 2b plus c. 0 equals 49a plus 7b plus c. And finally 8 equals c. What I have now is a system of 3 equations in 3 unknowns that I can solve and find values for a, b, and c. Since I know from the third equation that c is 8, I can immediately substitute 8 for c, and then I'll only have to solve a system of 2 equations in 2 unknowns. So I'm going to write this with the 0, the equal sign on the other side, make it a little bit more direct. I have, or more commonly written, 4a minus 2b plus 8 equals 0. Substituting 8 for c, and 49a plus 7b plus 8 equals 0. Now, typically, we write the variables on the left side and the constant on the right side, so I'll subtract 8 from both sides, and I have 4a minus 2b equals -8, and 49a plus 7b equals -8. I need to multiply the first equation by 7, the second equation by 2, and then I'll be able to add, and the b terms will cancel. Multiplying the first equation by 7, I get 28a minus 14b equals -56. Multiplying the second equation by 2, I get 98a plus 14b equals -16. And when I add, the b terms are eliminated, and I have 126a equals -72. So a equals -72 over 126, which simplifies to -4/7. I can divide both top and bottom by the same number and simplify to -4/7. Now, if a is -4/7, I can substitute that for a in this first equation. 4a minus, we'll do this one right here, minus 2b equals -8. So I have 4 times -4/7 minus 2b equals -8. This gives me -16/7 minus 2b equals -8. Adding 16/7 on both sides, I have -2b equals, I'll write this as sevenths, -56/7 plus 16/7. So -2b equals -40/7. Dividing both sides by -2, I have that b equals 20/7. I have the value for b, the value for a, and the value for c. So we can use those values to write the quadratic function. We substitute -4/7 for a, 20/7 for b, and 8 for c, and we have the equation of the quadratic function. Now we're asked to find its maximum or minimum value. To determine whether it has either a maximum or a minimum, we look at the coefficient of the x squared term. Since it's negative, the graph would be a parabola opening down, and there would be a maximum function value. So to find that maximum function value, we will find the coordinates of the vertex of the parabola. To do that, we remember that the x-coordinate of the vertex can be found by the opposite of b over 2a. In this case, that would be the opposite of 20/7 over 2 times -4/7, which is the opposite of 20/7 divided by -8/7. And we divide by a fraction, we multiply by its reciprocal. So that equals the opposite of 20/7 times -7/8. We have the opposite of a negative number, so it will be positive. The 7s will cancel, and I will have 20 over 8, or 5/2. Now this is the first coordinate of the vertex. The second of the coordinate of the vertex I find by finding f of 5/2. That is f of 5/2 is -4/7 times 5/2 squared, which is 25/4, plus 20/7 times 5/2 plus 8. If I calculate this out, I find that that is 81/7. That is the y-coordinate of the vertex, and that is the maximum value of the function.